This is Oral Rehab Lecture 9, Part 4, Screencast 4. And we're we're still contemplating here the different styles and types of hearing aids. We resume at slide 14. In slide 14 here, we're looking at the family of in-the-ear types of hearing aids. The in-the-ears kind of may seem like a weird name to you, but or a weird category name, but it was in contradistinction to the behind the ear, or BTE. So the BTEs historically preceded the ITEs. And again, the distinction with the earliest ITE is that all of the product, all of the electronic stuff was built into the shell, into the ear mold, into a sort of a hollowed out ear mold is the best way of thinking about it. And it was worn in the bowl of the outer ear, in the concha, and then into the ear canal. What sort of happened also as things got progressively smaller is that these ITEs, this family of ITEs, represented sort of different just reductions in size. So the ITE is sort of the bigger of the three. ITC was in the canal, which just represent a miniaturization. And now what's called the CIC are completely in the canal, is even smaller yet. Now I had shown you in an earlier slide set, I had shown you the Lyric, which is a deep-seated, completely in the canal type of product. So again, the whole intent of these is simply to get them smaller and to make them either, as in the case of the Lyric, something that is not visible to the eye because it's recessed into the ear canal deeply, or something that has the perception of being not as noticeable. And again, we deal with the perceptual aspect of it. If we look at this first, at this ITE type of product, basically, essentially, what are we looking at is this, for a functional way of thinking about it, is an ear mold which is hollowed out. So it's a built-up, it's the same process that an audiologist or a dispenser would make. I would take a cast of the spaces of the outer ear and, of maybe this part, that much of the ear canal. I would make a cast of that. This shape in here is kind of curvy. If we're looking at it from the top, it has kind of an S kind of curve to it. So I would take all of this space in here with a plastic impression, and then you'd send that off to get an ear mold made. Well, in the case of the ITE, that impression would then get sent to the hearing aid manufacturer. They would build a hollowed out earpiece that doesn't need to go as far down as as the impression would be, and then inside that shell they insert the electronics, and there's actually a faceplate here. So this is actually hollowed out, and then the hearing aid is built on this faceplate, and then it's just glued together. There's a seam that you can see on these, and that's how they kind of build it. The receiver is way down here. The microphone is out here. There's a battery drawer there. So all of the same components are here. And that's, so the ITE takes up the outer bowl of the ear. If we look at the CIC, we're basically looking at a product that has somewhat more of a recess. You still take the impression of all this area in here, but now when they build it, they only use this portion of it, so to speak. This, since it's recessed a little bit into that first bend of the ear canal, there's got to be like a little plastic tether that kind of hangs out so the person can grab it. Same thing though, there's a microphone here, the receiver's down here, amplifier, whatever's in there. Here's the battery drawer right there. So all of the same components are in here as well. And again, it's just meant to be smaller. If a hearing aid is a CIC, it sort of implies that the user can grab it and pull it out. Remember, the Lyric has to be taken in and out by the dispenser because it's recessed. The Lyric is down here somewhere in the ear canal, so it's even deeper into the canal. There's a couple other specialized fittings, and almost these are so specialized that not a lot of audiologists even do these. But one of them I'll just mention is called a cross type of hearing aid. A cross hearing aid stands for contralateral routing of signals, and really it was designed for when someone has one ear is within normal limits basically, and the other ear has a unilateral loss or a dead ear on one side. So that's going to mean that the person who has one unaidable ear means that sounds originating on their dead side, they don't hear very well because of head shadow effect, because that high frequency sounds presented to that side of the head, high frequencies bounce off of the head, they don't get to the other ear with the same amount of intensity. So it makes it harder, even in a one-eared listening person, unless they move their head around, to be able to hear what's happening completely and with complete high frequency fidelity of what's going on their dead side. So this is really more of a sort of a situational problem for this particular person. Now, most people who have this circumstance of one normal, one dead ear, quite frankly, do pretty well because they can just move their head around and they know how to put themselves into position so that their good side is to the side that they need to hear, or they position their head kind of on a midline. So, in all practical terms, this particular population of persons with hearing impairment does very well. However, there might be some circumstances in which an amplification system might be beneficial to them. So this was devised, decades ago, and not really used as much as you might think, even for people who have this particular problem set. The point of this is you put the microphone on the dead side, and you actually take that microphone and deliver it to the good ear. Since it's delivered to the good ear, it sounds a little bit different than the normal input to the good side. And so the idea here is that if someone were to be sort of whispering into the person's, let's say their dead ear is their left ear, whispering into the left ear, it's actually going into this microphone, which then goes over to the right ear. And so the person hears it. So anytime I fit these on people who are long-standing unilateral loss people, their initial response is, "Oh, that's kind of fun. Would you want to buy it?" No. This might have more of an application for someone who might have suffered a sudden onset of hearing loss. So an adult with adult onset hearing loss hasn't had the opportunity to adapt their behaviors to one-sided hearing. They have more of a chance that it might be successful. Now, for reasons that I don't understand, except that there are underlying financial reasons, as it explains a lot of things, there's a variant of this sort of contralateral stuff called a BAHA, which stands for bone-anchored hearing aid. And so the bone-anchored hearing aid is intended for the same population and for maybe a couple of other populations. The bone-anchored hearing aid, or BAHA, can be used in this cross-hearing type of application, because if I put a bone conductor device on somebody, it's going to go always to their better hearing ear, is going to be the ear that hears it. So the other application of the bone-anchored hearing aid is if someone has a purely conductive hearing loss. Let me get back to this. Has a purely conductive hearing loss, or has a condition in that ear. For example, they've got a draining ear that if you put an earpiece in that ear, it would make the drainage and the infection worse. Some people have an infection in their ear that will never go away just because of the nature of the infection. And so it might have, so their care is to keep their ear dry. And if you plug it up with an ear mold, then just the natural moisture of the ear is enough to make whatever the underlying organisms proliferate and cause drainage. So there is a very small subset of people who would benefit from in my view, a small subset based on pathology that might benefit from this bone-anchored concept. And the idea with the bone-anchored concept is just what it says, is that in this case the surgeon drills a screw into the skull bone and has this sort of a built-in screw that has this osseo-integrated implant. The same company, by the way, that builds cochlear implants builds the BAHA, just so you know. And so they screw this into the head, and then this takes a while to kind of integrate into the bone. And then once it does, then you take this this device here. Sorry, you take this device here, and so here's the screw. What they call an implant, but basically it's just a screw drilled into your head. And then you take the hearing aid part and you just sort of snap that into there, and now you've got a bone conduction fitting, so that when this microphone on here picks up sound, it causes the output here to vibrate, and vibrate this screw in your head. It vibrates your skull. The vibration goes across your head and goes to your inner ear, wherever your inner ear is on either side. And so you get hearing based on this particular kind of concept. Anyway, it's kind of a niche product, but it's sort of unusual and weird. All right, let's move on to the second decision that consumers have to make, which is what level of technology. The notion here is that technology is the basic underlying technology is pretty much all digital. Remember, the older hearing aids were what are called analog type of hearing aids, and there is still certain levels of analog processing that occur in every hearing aid. For example, a microphone is an analog device. It converts acoustic energy into an electrical signal. The receiver is an analog device, which takes an electrical signal, converts it back into acoustic energy. But what we're talking about when we're talking about a digital hearing aid, what we're talking about is the part of the hearing aid that actually does what we consider to be the amplification. And again, strictly speaking, in a digital hearing aid, it's really not so much amplification. That's really more an analog concept. But what we're referring to is the processing. And if that seems like it's a little too nuanced, I'll sort of agree with you on that. But nonetheless, almost all hearing aids that would be available these days are digital. Again, the old school, completely analog, where the amplification stage was an analog amplifier. Some of those are still around. And by the way, there's no great data either by use or numbers of hearing aids sold or by performance that necessarily determines that or demonstrates that digital processing is different from a better fit analog hearing aid under sort of quiet conditions. Now, the hope is that the digital processor is going to be better and provide more flexibility in more noisy conditions. And there are some studies that suggest that that's the case, but really not enough that it's, that's the cardinal rule quite yet. Now, there are different levels of digital in terms of sort of, if you want to think about it like you buy paint, good, better, best kinds of stuff. And so the different levels of digital are going to affect the cost. And this is going to have to do with sort of really the degree to which the hearing aid can be adjusted and sort of those kind of characteristics. But most every hearing aid that anyone's going to end up purchasing these days is going to be a digital processor. Third consumer decision has to do with the features and options. One of them that you're going to see that is going to be widely recommended is an onboard telecoil. Now, a telecoil, and I showed you that, and you can go back to lecture 8 to kind of see what that is. The telecoil is an alternate input transducer, alternate to the microphone. What the telecoil picks up is electromagnetic energy and then sends that to the amplifying circuit, not acoustic energy. And again, the application for the telecoil initially was for use with the telephone, but now is also used for large room amplification systems that use what's called an induction loop. This will be a topic of lecture 10. This is really for public access and for public accommodations for persons with hearing loss. So more for public aspects here. Again, it's recommended for use. And again, would likely always be recommended in a pediatric hearing aid fitting for the same reasons, that it provides alternate inputs to the hearing aid. Secondly, many hearing aids could have the option of having a remote control. That's something that's a user benefit, perhaps. Hearing aids typically have a single microphone, or you can get what's called a directional microphone or a multiple microphone arrangement. As we'll see probably again in lecture, maybe toward the end of this lecture, I think, and in lecture 10 again, you'll see the advantage of something called the directional microphone is expressly to increase the signal-to-noise ratio. Okay, so that's what the advantage of that is, and that's why persons recommend that. And then the other sort of feature and option is the degree to which, well, whether you have it and the degree to which you can have connectivity capacities to external devices, like to your telephone, like to your television, like to other things that might be externalized devices, and then also from one hearing aid to the other. So if you've got two hearing aids, the two hearing aids can kind of work collaboratively based on where the input signal is, predominantly on one side versus the other. The last consumer decision has to do with whether you get one or two. And again, we say that if you're going to get one hearing aid, it's monaural. We get two hearing aids is binaural. Generally said, if a person has a bilateral, symmetrical, high-frequency sensorineural hearing loss, I will always recommend binaural hearing aids, and for several reasons. So, obviously, by two, it's going to increase the cost, but there are really compelling scientific reasons why two is better than one. Most people will come in and you say, well, I recommend that you get two hearing aids, and they'll say, well, I don't feel like I'm that bad off. I don't really need to. Well, I see you're wearing eyeglasses and not a monocle. I mean, you got two ears. What's the logic here of why you wouldn't want to have a hearing aid in each ear? But it's the psychology of the user that they somehow feel less conspicuous if they have just one. So it's always kind of a major counseling point. But here's the reasons why I can say with very clear conscience that this is a good thing. The primary one for binaural amplification is that it eliminates head shadow effect. Now, I'm going to bet that you had a coverage of head shadow effect in the acoustic sections of your prior course. And head shadow effect simply means that high frequency energy bounces off your head when it's directed to one side and doesn't get to the other side. So if I had a hearing aid on my right ear, and had a high-frequency hearing loss, even in bilateral symmetrical high-frequency hearing loss, the sounds would hit my left ear and bounce off of my head and wouldn't get to the other side. Remember that head shadow effect is the basis for sound localization for high frequencies. Again, that was part of acoustics that you might remember. And so the notion with a head shadow effect is that a person has bilateral high frequency hearing loss, they're not going to hear it even in their hearing aid. So right there, that's the primary benefit to recommend two hearing aids. There's also having two hearing aids enhances sound localization, which is again an important aspect, I think, on a much sort of subconscious level. And then there's some other sort of psychoacoustic factors that make it better. When you have two ears working, you don't need to have one of them quite as loud, quite as powerful. So there's a summation that occurs when you got two ears working simultaneously. Additionally, you've got when two ears are working, it does also seem to improve the signal to noise on a sort of central nervous system processing basis. So there's certainly some advantages for having binaural. This is Screencast 4. We'll adjourn now to Screencast 5.